Thank you very much to the organisers for inviting me. So this is a paper with Philippe, Antonin and Richard Blunder, who's not here. And it's the first time we've really presented it in public, so we're super interested to hear people's comments. So what's the motivation of what we're doing here? We've known for a long time that innovation and productivity improvements are key drivers of growth. What we're interested in this paper, and I think is increasingly of interest politically around the world, is in how the benefits from this growth are shared in society. You might say that Brexit was largely a result of us not understanding well how the results of growth were shared in society. So there's a large literature that points to the effects of skill bias technical change on growing inequality, so particularly thinking about growth at the top end of the distribution. But from a very large literature, we also know that firm heterogeneity is very important in describing variation in wages, both cross-sectionally and changes over time in many countries. And so what we're interested in this paper is kind of bringing some of these ideas together to try and understand the role of research and development and innovation as a driver of these differences in wages for sort of observationally equivalent workers when they work in different firms. So another sort of side to the motivation here is that we see high and persistent differences in productivity across firms. That's been documented in a large number of papers. Syverson in his JP paper summarizes much of that, showing that, again, very similar firms have very different levels of productivity. So if we look, for example, in the US at plants in industries that are producing very similar things, we see, some plants are about producing almost twice as much for the same amount of inputs as others. And so the question is, what do those levels of differences in productivity feed through into wages for workers? And how do they feed through? What are the mechanisms by which that happens? So what we're going to do, the contribution that we're making to this literature in this paper, is we're going to, first of all, we're working in the UK. We're going to be using matched employee-employer data. And the first thing we're going to do is document that differences across firms and within firm over time in innovation intensity, so R&D intensity, are one driver of between-firm differences in wages, and one that we think is reasonably important. I'm not going to hugely be able to quantify the degree of importance, but I'll try and show you that it is non-trivial and is not the only factor driving that, but it is one of the important ones. So we're going to do this using this sort of novel matched employee-employer data that has research and development activities of the firm as well. Somewhat surprisingly, and kind of the key result of the paper that I'll both show you and then try and convince you is a real result and that we have some intuition for why it exists, is that this sort of premium to working in an innovative firm is higher for workers in lower skilled occupations than it is for workers in higher skilled occupations. And so that's going to be the kind of key part of the talk, really, is to try and first show you that empirically and show you that that result's robust, and then to provide a model that gives you some intuition about why and some auxiliary statistics that try and convince you that this is true. So the story, so we're a bit surprised to find this result. It's not what we started out looking for. So we tried to understand that by developing a little kind of simple model in which there's complementarities between low and high skilled workers. And these increase with innovation. And the model sort of captures the idea that low-skilled workers can have a very damaging effect in firms when they're complementary to the high-skilled workers. And this is the kind of idea that's in other papers in literature, for example, Garicano and Rossi Hansberg. And we'll try and show you how that model works and that we see that in the data. And hopefully, by the end, convince you of that. So, yeah.
Does the worker include the CEO?
No, the worker is not going to include the CEO. That's a great question. So in the data that I have, I will not have CEOs in the data. We could, in theory, have that, but no. So I'm going to be talking about employees that earn a wage. So if a CEO is in, so it's going to be all employees that earn a wage. Okay, so first I'm going to show you some of the data. So the kind of main contribution, I guess, is empirical and then matching up the theory with it, but I'm going to spend a bit of time telling you about the data we have, showing you some motivating statistics and the robustness of those, and then show you this simple model that tries to give us this intuition about why this somewhat surprising result might exist, and then some additional support for some of the kind of key assumptions of the model to sort of lend support to the mechanism that we think it underlies the result we get. Okay, so the data that we use is for the UK. It's from 2004 to 2014. So we marry up 3 pieces of data. I'll talk about the 2 first and then show some results and then talk about the third. So the 3 pieces of information we put together are data on wages and earnings from the annual survey of hours and earnings, ASHE, which I'll tell you more about in a second. Data on research and development expenditure at the firm level from the Business Enterprise Research and Development. So these are both data that are collected by the UK government and are pretty high quality. Then later on, I'm going to match in the ONET data for people who know what it is. We heard some in papers using data like that earlier. That's from the US at the occupation level on the characteristics of occupations and the workers in particular types of occupations. But I'll leave talking about that until I get to those results. So the main data we're going to use is, so we start with ASHE, which is a 1% sample of all UK-based workers based on their national insurance number. So it's a panel, so we follow, in 1 year, everyone that has a national insurance that ends in number 2 is sampled, or 1% of the population that has number ending in 2, and then they're followed throughout their career. Okay, so we're going to have the same people over time, so we're going to exploit that. That's going to be important for identification, that we're going to see people moving jobs between firms as well as staying within a firm and experiencing changes within the firm. And I'll talk to you in a minute about the measures of, it's a very detailed survey of hours and income. I'll tell you in a minute exactly how we use that. So we match that to the Business Enterprise Research and Development Survey, which again is a survey conducted by the government. It's a census for all establishments with 400 or more employees, and below that it's a random stratified sample. For everything I talk about today, we're going to condition on establishments that have more than 400 employees. They account for the bulk of research and development in the economy. Clearly, they don't account for the bulk of employment, but we can show that most of the results we get are robust to using larger samples. I'll mention a few statistics about wage distributions for the bigger sample, but besides that, I'll talk only about the sample that's based on larger firms. We're going to condition on private firms. So this is a 1% sample of the entire economy. So we have the public sector, etc. So I'm going to condition on private sector firms that have more than 400 employees, but it's going to be the whole economy. So it's going to be the service sector and the manufacturing sector together. So these firms together, the match sample together, accounts for around 70% of research and development done in the economy. And as I said, we can show robustness to other samples. We have around 150,000 employees that we follow over time and around a bit over 6,000 firms. Okay, so the ASHE data is very detailed information on labor, income, and hours for the workers that are sampled. So we have many different measures of income and hours, and one could spend a lot of time talking about exactly how one measured that. What we're going to use is hourly wages. So we're going to not account for periods of unemployment, for example. We're going to count for differences in hours worked. We'll have many controls to deal with things like part-time workers and etc. But so the main results that I'm going to show you are going to be using hourly wages, including bonuses and incentive pay. Both of those things are pretty important for some parts of the economy, bonuses and incentive pay. And again, we can show robustness to these specific measures, but I won't do that. So the ASHE data also has some information on the individual, like gender, age, tenure in the firm they work for, and the occupation they work in at a very detailed level. What it doesn't have, though, is very good information on the individual in terms of their education or the skills they have and other demographics about the individual. So that information we're going to use occupation, the occupation that they work in. So we're going to use the average characteristics of people that work in the occupation that that individual is working in. Okay? So individuals may shift occupations, we may see that in the data, so we'll use the skill level of the occupation. So we're going to use, as I said, later on, I'm going to use the ONET data, and I'll talk about that when I match it in. For the first set of results, I'm going to use the National Qualification Framework in the UK, which is the sort of framework that's used to decide immigration. So it's a clear set of rules that are defined each occupation based on the qualifications that you typically require to be in that occupation. And immigration laws are more lenient the higher the qualification level. So pretty much everything I'm going to talk about, I'm going to divide occupations into 3 skill levels: low skill, intermediate skill, and high skill. And this, I said, this is, one of our key results is going to be about the premium to working in an R&D firm for these different groups. So the low skill workers are workers that largely, there's no formal qualification required to be in that job, but you may receive a lot of on-the-job training. And what I'll try and convince you later on is that these occupations are very heterogeneous. Some of them, like a cleaner, really requires very little training or firm-specific skills, whereas some others, like process plant operatives or specialist plant operatives, may in fact be very specialist and very idiosyncratic to the individual firm, and there may be a big premium to the match and the investment that the firm makes in the worker. Then we have intermediate skills, and then high skills are people who typically have some type of degree, and that's very, maybe their skill level may be very verifiable. And a key thing that I'm going to highlight later on is that for the high-skilled people, we may think that it's much more observable, their quality is much more observable when you're taking a hiring decision than for the low-skilled guys, because they have, formal qualifications. Okay, so this just shows you some idea of the kind of, in the data, of the wage data. So this is by skill category, and the hourly pay, then the percentage of their pay that's incentive pay and that's overtime, and then annual earnings. So I'm going to use this hourly pay that includes incentive and overtimes, but we have other measures like annual earnings, etc. And so you can see that incentive pay and overtime can be very important for some types of workers, and they're differentially important, so it's quite important that we include them. So one other just sort of aside about the data. So, we're interested in how the rents are shared among workers. And so one thing, a big motivating idea here might be that we're interested in understanding the role that this plays in overall income inequality. And so if we look like at OECD data, we see that the ratio, if we compare the average wage of workers, the highest paid 90% of workers to the lowest percent at 90%, where we take account of the tax and benefit system and the entire sort of economy, the kind of way that the pay and taxes and benefits, we see that the top of the income distribution in the UK, the top 10% is paid about 11 times the bottom of the income distribution. Okay, so now what we're looking at is these guys that are working, because they're in ASHI, and we're comparing across different firms. And so just to give you some idea of how that compares, in the data that I'm using, the ASHI data, that number is 6.7. So we still get, we've gone from 11% when we consider all of taxes and benefits and the entire system to 6, which is still a very considerable amount of inequality. So even though, of course, we're looking at a subset of the population, this is still, a substantial part of the aggregate amount of inequality that we see. Then we're further restricting our sample to large firms, and the ratio of the 90-10 is almost exactly the same in that. So some people have asked, we've discussed this paper before, about whether we're really, restricting ourselves by looking at large firms to a part of the economy where there's not nearly as much income inequality as might motivate the original question that we're interested in answering. But that doesn't seem to be true at all. There's still very substantial income inequality, even in this group. So we focus on large firms because of the data, because the BIRD is only a census. The R&D data is only a census for over 400, and so we don't have a nice panel. So we show robustness so we have 2 random samples that we would then match to each other, and the statistics of dealing with 2 random samples are just messy. So we show robustness to that but for the main sample, you know, it's a substantial part of the economy. It's statistically much easier to deal with. Okay, so we're going to look at the effect of R&D on wages. So just to emphasize two things. So one is we're going to do this at the firm level, not the establishment level. So the data that we have is at the establishment level. So an establishment is, broadly speaking, a plant. It's a bit bigger than a plant, but it's like a line of business, basically. But, you know, for a big firm, it will do R&D in one establishment and production in another establishment. And so the idea we're looking at the firm level. So we're aggregating this up to the firm in all cases. We include both intramural and extramural R&D. So we know a lot about R&D. Here we're just going to use R&D intensity. In principle, we know more about the type of R&D and how they're doing it. So everything I'm going to show you, I'm going to use the log of R&D intensity, which is the ratio of R&D to employment. I'll also, actually I think I won't show this, but in the paper we show that we show what's driven, what of the identification is driven by the 0-1, does the firm do R&D or not, versus the intensive margin of R&D. Okay, so now I'm just going to show you a couple pictures to get a feel for the data, and then show you some of the key results. So first of all, higher paid workers are more likely to work in a firm that does R&D. So along the x-axis, I have centiles of the wage distribution for think of it as the entire economy more or less. And on the y-axis, I have the share of workers that work in R&D firms. So if you take a random worker at the top of the wage distribution, they're more than twice as likely to be in a firm that does some R&D than if they're in the bottom of the wage distribution.
Do you have information about, can you get information about intangible capital that adjust R&D in these firms? Especially for the magnitude, it could be important to look at a broader measure. So R&D is 3% of GDP, right?
Yeah, sure.
So thinking about that small amount being able to shift the wage structure in the aggregate.
Yeah.
A little bit of distraction.
We could do...
intangible.
Yeah, so I'm not really going to here try and link it to a driver of the entire shift of the wage structure. I'm going to ask how much of the firm-specific component, I'm not even going to come down to ask how much of the firm-specific component it accounts for. It's just I'm going to show it has a non-trivial effect, and so it's some part of it. The answer is probably we could for more recent years. We could also look at productivity, for example. So here we've been particularly, this is a part of a bigger agenda, we're particularly interested in innovation and the effect that has on workers. But yeah, we could do. So that would make the effects bigger, I guess. Okay, so this shows you that if you kind of look at a similar thing but cut a different way, if you look at the R&D intensity of a firm, then the higher the R&D intensity, the higher the average wage. And this is, so the two things to point out, because I'm going to show this in repeatedly. So this 0 here is got a lot of firms. This 0 here has a lot of firms. These are all the firms that don't do any R&D. And then these are the firms that do R&D, and there's many fewer firms here. In a bit, I'll show you the distribution of firms, but there's much fewer firms here, and there's many more here. And this is the log wage relative to labor market means. So later on, I'll do some regressions where I'm going to take out a lot of things, but in most of what I'm doing here, I'm just, in the UK, there's something like 200 odd labor markets or something, travel to work areas. So we're just residualizing the wage to take out that simple effect. And this is just plotting the log residualized wage against the R&D intensity of the firm. And so you see that the higher the R&D intensity of the firm, the higher on average is the wage of workers in that firm. And this is true for workers at all ages. So, as workers get older, their wage increases and then dips. This is a feature of most data on wages we see. But at any age, working in an R&D firm means that you have a higher wage. And that's higher later in your career, but it's true everywhere throughout your career. Okay, so that last picture just already suggested something, that there may be many reasons the type of people that work in R&D firms may be different than the type of people that work in non-R&D firms. And what we really want to know is the effect of R&D, not just the selection on observables. So, correlation could reflect many things. So we know, and here I'm showing you, if we compare R&D firms to non-R&D firms, the R&D firms employ more men, and men are on average paid more than women. They employ more full-time workers who may earn higher wages. They employ older workers on average, and we just saw that older workers tend to earn higher wages, and the tenure of workers is higher.
If you do the R&D intensity measure with firm size, it's very steep. That suggests that there is a positive R&D with firm size.
There is a positive correlation between R&D and firm size, and there's a positive correlation with wage and firm size. We know that from the literature. Both of them.
Trying to come from McBloom's.
Yeah, so I'm going to show you a regression in a minute where I control for all that. So all those correlations exist in the data. I'm going to show you a regression with wages where I have all of that on the right-hand side. So that's what I'm trying to say here, is that there's many reasons why we might think that wages might differ between innovative and non-innovative firms that may not be due to the effect of innovation. So I want to control for all of that. So I'm going to show you some regressions of the log wage where I'm going to control for some stuff. So I'm going to put in log R&D intensity is what I'm going to be interested in. And then I'm going to have a bunch of controls that are going to include observable stuff like this, observable things about the firm, and then a bunch of fixed effects, which will vary and I'll tell you about, but will basically be things like individual fixed effects, occupation, labor market, firm, and year. Okay? To try and show you that correlation I just showed you is robust to those. So that's what I show you here, and hopefully you can read. So this is the log wage on the log of the R&D intensity, which is what I'm interested in. So this is positive and significant everywhere. And I have different controls. So I have controls for age and age squared, tenure and tenure squared, employment in the firm, the gender, whether you work full-time or not, and then some fixed effects. So the fixed effect here is labor market time. So that's basically replicating the picture I just showed you. And we see a sizable, I'll interpret this economically in a minute, but this is pretty sizable and statistically significant effect. Here we add occupation. So this is now labor market occupation time effects. So these are separate time trends for every occupation in every labor market. Okay, and so that reduces the result by not quite half, by about a third, but still positive and significant. Here, and this is going to be kind of our preferred specification, we include individual fixed effects. So the plus there means we have individual fixed effects and we have time effects, not multiplicative, but separate. So when we include individual effects, the coefficient goes down, but is still significant, and I'll tell you in a minute, economically non-trivial.
So this is workers.
This is I as worker, exactly. And the final column is firm fixed effects. So the firm fixed effect, and this is something I'd be very interested in talking to people afterwards, the firm fixed effect we think absorbs too much almost. So we can show that with even individual and firm fixed effects, we do get some results. Our preferred interpretation is this, but is this specification, but we could come back to that once I show you everything, all of our results.
So how many workers switch firms? I would have thought that 3 would be less demanding than more demanding than 4.
You would have thought that 3 would be more demanding. It's not so much about the demandingness, it's about what the identification. So what 3 is doing is identifying the effect of employment on my wage by exploiting when I switch firms and when my firm changes the amount of R&D that I do while I'm working there. And that seems to us the form of identification that we want to be exploiting. In the firm one, where I would have to articulate more clearly exactly, but I think we don't feel that that's the identification we're getting in that is good. Okay, so we get a positive and significant effect, so that's great. So we want to look into that a bit more. So one of the things I said is that we know that distribution of skills across the R&D.
It's 10 minutes left.
Yeah. Okay. So we know that the distribution of skills varies across firms, with the degree of R&D intensity. And so one of the things, so this is really the key result of the paper, that if we look at workers in low-skilled, medium-skilled, and high-skilled occupations, at how the R&D, the wage relative to the labour market mean, as I showed before, varies with R&D intensity, we see that for high-skilled workers, they get paid a similar wage relative to their labour market mean, regardless of the firm they're working in. Whereas for low-skilled workers, that's not at all true. The premium to working in a high R&D firm is much higher. So their wage is lower everywhere, but the premium to working in a high R&D firm is substantially higher. Okay, so that was puzzling. So this is the main result, and we can show that holds. This is running the same regression with individual fixed effects. Now low-skilled, medium-skilled, and high-skilled separately, and we can see all of the result is coming from the low-skilled guys. The premium for the high-skilled guys is 0. So that's just what I showed you in that picture. So we can show that that's robust to a lot of controls. So one thing to say is just, what does this number mean, 0.08? So if I look at what the impact of moving a one standard deviation from in a firm, the level of R&D that a firm does, that increases wages by around 2.3% for low-skilled workers. So that's a non-trivial result. It seems quite believable to me. It's not massive, but it's non-trivial. Okay, so we want to understand that. That's a little bit of a surprising result. It's not what we expected to find. So what explains it? So we build a model in which there's complementarities between some workers in low and high-skilled occupations. And the skills of workers in high-skilled occupations are less firm-specific than those in low-skilled occupations. So workers in low-skilled occupations either have very generic jobs, like they're a cleaner, in which case there's no complementarity, or they have jobs that require firm-specific knowledge, like a plant operative, and they're complementary, and they can command a very high wage if the consequences of them leaving are very important for productivity, for the production of the firm. And so this gives the workers in some low-skilled jobs, like those ones that are complementary, bargaining power and higher wages. Okay, so we write down a little model that basically delivers that. So we have two workers, high-skilled workers with quality Q, low-skilled workers with little q. So it's a partial O-ring model. So what that means, we have this part of the production function in which high-skilled workers and low-skilled workers are complementary, and then this part of the production function in which they're not. And the weighting, so that the flatness of the firm structure is going to depend on how important this part of the production function is relative to that. Okay, so if this is 0, then they're purely substitutes and there's no complementarities, and if this is 1, then low and high-skilled workers are more complementary. And we know from other work that innovative firms have flatter structures, i.e. lambda is closer to 1 than to 0. And so our idea is that we can kind of look at variation, look at comparative statics in this lambda term, and that will tell us something about the effects of moving to higher R&D firms on these workers that are in the more complementary, in firms that have these more complementary type of low-skilled workers. Okay, so we can show in this model that you get that moving to a flatter structure leads to a higher return to low-skilled workers. So the firm engages in, so there's a couple of assumptions we need to show that, and I'm going to tell you those assumptions, and then I'll show you some statistics that try and support the idea that these assumptions are valid. Okay, so the firm engages in separate wage negotiations with each worker, which yields these equilibrium wages. We assume that the quality of the highest skilled worker is higher than, so if negotiations fail, then what the firm has to do is go to the market and obtain just a standard high or low quality worker. And we assume that the worker that they have at hand is higher quality than the one that they get out in the market, and that high skilled occupation workers are higher quality than low skilled occupation workers. So importantly, we assume that there's less risk of hiring a bad worker in the high-skilled occupation than the low-skilled occupation. So this is a key assumption, and one I'll try and convince you has some validity. So the idea is that there's kind of less asymmetry in information. You can read off people's CVs when they're high-skilled guys. So what that means is that the difference between the guy you have and the guy that you'd get out in the market for the high-skilled guys is lower. The difference in that is lower than for the low-skilled guys. Okay, and so we can find equilibrium wages for workers in low-skilled occupations and in high-skilled occupations. And what that yields is an expression that, that is here, which is that the equilibrium wage for workers in low-skilled occupations, the effect of increasing competition, increasing innovation or increasing the flatness of the structure is going to be more important for these low-skilled guys for these high-skilled guys. And that's going to be true as long as this difference, your ability to, the consequences of having to go to the market for another high-skilled guys is sufficiently small. Okay? So that the low-skilled guys that are complementary are really important to production. So that's going to be the important thing that kind of drives this inequality. Okay? So what this model does is give us, first of all, an empirical prediction that low-skilled workers that remain in a firm benefit more from an increase in R&D than high-skilled workers. So that's the picture I just showed you about before. So this model delivers us the prediction that we just saw before. It also gives us two other predictions. One is that low-skilled workers stay longer in more innovative firms as more time and money is invested in them to move them up from the kind of low quality to higher quality. And the second is that this main effect is stronger the lower the quality of potential replacements in low-skilled workers. Actually, I'm not going to be able to show you anything on that. So I can show you, though, that with regard to this, that low-skilled workers stay longer in more innovative firms, we do see that. So if we look here, if we take firms that do no R&D and then look at the distribution, percentiles of the distribution of R&D, and this is the average tenure in the firm, we see that for low-skilled workers, the tenure increases very dramatically the more R&D intensive the firm is, as predicted by the model. Then the second thing that we can do is try and show you some statistics that support the idea that, that this complementarity, that low-skilled workers of a certain type that work in high R&D firms are more complementary to high-skilled workers than low-skilled workers working in low R&D firms. So to do that, so as I said, our theory suggests that an important reason that workers in low-skilled occupations in high R&D firms get a higher wage than observationally equivalent workers, because we've controlled for everything else, is because they are more complementary. Okay, so to show this, so we match in this ONET data. So these data are collected from workers in the US and aggregated to the occupation level. So they provide detailed measures on the characteristics of occupation and training of workers, among many other things like tasks. So we match them in at the occupation level, and I can show you statistics for three things, basically. One is the answer to the question, what are the consequences of you making an error on your firm's profits? What is the impact of decisions that you make on other workers in the firm? And then how much training do you get, either on site or on the job? And so what we see if we split that, so if we look at the consequences of a worker in a low-skilled occupation making an error, we have by the skill level of the occupation and by terciles of the R&D distribution. So this is rated on a scale of 1 to 5, and so this says that for low-skilled occupations, the consequences of making an error when you work in a firm that doesn't do R&D are lower than when you work in a firm that does high R&D. And here I provide statistical tests of that, and so I show, like, if you just do a test, for example, comparing the no R&D to the high R&D column, you can see that for low-skilled occupations, it's very important. It's the consequences of making an error when you work in a high R&D are much more important than when you work in a low R&D, and that's statistically significant. Whereas for the high-skilled guys, it's actually marginally positive. So it goes the opposite way. We see the same thing when we look at the impact of making decisions. So for low-skilled guys, the impact of decisions on your workers is much higher when you work in a high R&D firm than a low R&D firm, and in fact for high guys it's the opposite and marginally positive. And then the final thing is that we see that the low-skilled occupations get much more on-site and in-plant training when they work in high R&D firms than when they work in low R&D firms. So here I'm showing the proportion of workers who work in occupations in low R&D intensity firms that say they get either none or this level of on-site training. And you can see that this is much higher than that. So fewer workers get no training, and many more workers get a lot of on-site training. So the types of occupations that low-skilled workers do in high R&D firms are ones that have much more on-site and in-plant training and on-the-job training. That's corroborative of the assumptions and the way we set up the model. So sorry I went through that so terribly quickly. We can show robustness to a whole bunch of things. And so to conclude, only a few minutes late, what we do in this paper is we use new match data. So one of the cool things is we've got this R&D data matched in at the plant level to show something that's a bit surprising, that the premium to working in an R&D firm is higher for low-skilled workers. We propose a model that's consistent with this, and it seems to explain it, and then we provide some additional empirical support that suggests that some of the key assumptions of the model and that the mechanisms that work in that model lend support to that as an idea.